Hi folks, I hope that everything is fine at your end. So we are gonna start a lecture series on design of reinforced concrete structure. So before going to the actual topic, I believe that it will be appropriate to have a discussion on design philosophy of reinforced concrete structure. So next few slides, particularly this class, we will try to have some discussion on the design philosophy which is adopted for designing of reinforced concrete structure. Why is it particularly important? Because the concrete structure is not a homogeneous material. We are calling it a reinforced concrete structure. That means two types of material. One is concrete and other is steel. They are present and their mechanical behavior are different, and so they will be negotiating while carrying the load. So that makes the difference of reinforced concrete structure from other type of structural element. Of course, all of you are accustomed to this course IS 456 2000 by BIS, and also it's designed SP16. This will be very frequently required whenever you'll be designing a concrete structure as per the requirement of the Indian standards. And uh, one very good book for to be followed for developing the concept is Reinforced Concrete Structures by Park and Paule. You believe me that this book is excellent because this is the only book perhaps which talks about the mechanics involved in the behavior of the concrete structure. Most of the other books are conventional, they simply give the design steps, but why those steps are carried out, if somebody is interested to know that, then you should explore Park and Paul. And then, of course, just a there are many traditional textbooks. One of them is Limit State Design of Reinforced Concrete by P.C. Varghese. So, uh, let us just try to understand that what is we normally hear two terms very frequently, analysis and design. Let us first try to understand what is the difference between analysis and design. You know, analysis means finding for a given loading condition, finding out the maximum stresses and strain which are being generated at each and every point of the structure, or other way speaking, at each and every point of each member of the structures. That means knowing the stress and strain distribution throughout the structure. That is the objective of carrying out analysis. But why we are carrying out the analysis? We are basically carrying out the analysis for design. Because what is the objective of the design? The objective of the design is that we want to ensure that a structure which will face the kind of loading in its life period, it should be able to resist that loading without any damage to the structure or collapse of the structure, and at the same time it will be able to maintain the functional activity for which it is uh, constructed. So that is what is written here, that the design process analysis I have talked about. The design process contains provision of adequate member dimensions so that the stress obtained from the analysis can be carried out without causing the failure. So this is what we are going to focus on, reinforced concrete design of structures. Now, what is the general objective of these structures? You see, there are a few bullet points. The structures or design should have an acceptable probability of performing satisfactorily during their intended life. Why we are talking about the probability? Because in this world everything is probabilistic. If I say that I will do this work tomorrow, then it doesn't mean I must do it tomorrow. Then it doesn't mean that I am telling that I I will really be able to do the work tomorrow, because it may so happen that I may die tomorrow even, or something may happen so that maybe that I may not feel well, so I I may be in a position not to do the work. So that means whatever intention, whenever we are saying that we'll do something, basically we are expressing our intention or planning, and whether we will be able to do or not with 100% truthfulness, nobody can depict. There is some level of uncertainty, and that level of that uncertainty is expressed in terms of the probability. The so here, more logically, the point is mentioned that the structure so designed should have an acceptable probability. That means a very large probability which is acceptable of performing satisfactorily its duty during its intended life period. Then the design structure should sustain, or it will be able to carry all the loads and deformation within the limits of the construction and use. And then the design structure should be durable. And lastly, we can say that the design structure should adequately resist the effects of misuse and fire. So these are the environmental effects. There may be various other environmental effects. We have just listed the major one, but there may be in a ocean structure. It may so happen that the structure may be exposed to water which is uh, having chloride uh, dissolved in it, and so that may create some disturbance to the structure, or maybe there can be too much of salt, so which also may be not desirable for the health of the structure. So there can be different kind of exposure, and depending on the possibility of the exposure, the structure has to be designed such that it can survive. So you see that primarily whatever points we are talking about can be expressed in two ways. The first thing is that the dimensions of the structures should be proportioned in such a way that the strength it has will be greater than the stress which is occurring at various parts of it because of the loading. So this is the strength requirement. And second thing is that this strength requirement should be satisfied not only for a small duration but for a long duration, more or less during the entire life period of the structure. So this long duration maintenance of the strength is called durability. So basically we are looking for two terms. One is strength, other is durability while designing these structures. Initially we used to use working stress method. This method was very conservative because at that time the knowledge about the stressful behavior of the structure or the concrete or reinforced concrete was not very much clear. Therefore, people wanted to play safe, and we are having a standard beam section. You must have already read in the strength of material that if it is subjected to a bending, pure bending, then the strain distribution will be strength distribution will be like this, triangular, and hence the stress distribution will also be you know of similar profile, but of course of different value, because the stress sigma at any point is modulus of elasticity into the strain. But in this process, what happens? What happens is that we allow only the extreme fiber. We are so conservative. We allow only the extreme fiber to reach the maximum permissible value. Okay, maximum permissible value of the strain, and then maximum permissible value of the stress. But whenever you know that this uh, uh, you see, whenever more load is coming, then this, so at this maximum permissible value, if it is exceeded, then this fiber, this top fiber will undergo yielding. But then all the fibers above the neutral axis, they are having stress or strain much lesser than the elastic strain, and sorry, yield strain, and therefore their force carrying capacity, they could have also taken the strain up to this. You see, a fiber which is near the neutral axis, it can also take the same amount of strain what is being taken by the top fiber, but we are not in a position to use its strain carrying capacity, or other way speaking, the stress carrying capacity, because the stress carrying capacity equal to strain carrying capacity into the modulus of elasticity, that all of you know. So the that is why the reserve strength of the structure, that is why the reserve strength of the structure is not utilized. So there are some drawbacks which was noted. Uh, I mean, drawbacks of the working stress method which were noted. Firstly, it assumes that concrete is elastic, which is not true, as the concrete behaves always inelastically. Its stress strain curve is never straight. Then secondly, it uses factors of safety for stresses only and not for loads. Hence, this method does not give true margin of safety, because the load as well as the stress or the strength, everything is probabilistic. So these, and because of this probabilistic phenomenon, we introduce the safety factors, and here it is not completely done for the loads. Here only one factor of safety, which is typically called factor of safety in working stress method, is introduced, but no separate factor of safety depending on the level of uncertainty is used at various levels. So to make the design more rational, it should be taken care of. And then it also doesn't account for shrinkage and creep, which is a long-term phenomenon. And then after all, whatever we have discussed, that the stress strain carrying capacity of most of the fiber except the top fiber under bending is not utilized. Therefore, the entire design become uneconomical. That means we could have reduced the section size if we would have been able to use the fullest stress strain carrying capacity of the lower fibers, the fibers near the neutral axis. Then of course our dimension would have been small, but at that time it was relevant, because we didn't have the idea about the stress strain characteristics of concrete and steel, and so we continued with that. But once people continued the research, then then people found that they can do something more so that the stress carrying capacity of the fibers which are closer to the neutral axis can also be used, and that is introduced. All these drawbacks which are pointed out here is introduced in the limit state method, which we will talk about in the next class.